Okay, now I think I'm ready. So, welcome. My name is Marty, and this is CS193A, Android Application Development. And if you're here with us today, but you aren't registered for the course, the good news is I may have a seat for you. The course has been full, but we had a few people schedule change, a few people dropped. So if you're not enrolled and you want to get in, send me an email after class, and I will give you some more information about that. So might be able to fit in people who are trying to add the class. So that's the good news for now. This is a class about developing applications for the Android phone, the mobile phone platform. And so I'm Marty Stepp. I'm going to be your instructor, and I'm going to introduce my TAs in just a second. But just in terms of today, what we're going to do is we're going to go over the course information. I didn't make any copies of the handout because I'm lazy like that. I would lie to you and say that I didn't want to kill trees, you know? Didn't want to make a bunch of paper copies, but I have no regard for trees at all. I'm just totally lazy. So I didn't make any syllabus copies for you. But if you want them, everything from class will be posted at our website, which is cs193a.stanford.edu. And so just if you walk away with nothing else today, just write down the website address and go there, and that's where all the documents will be found. So I want to talk a little bit about this course. So I have a couple of slides here, so let me open up my slides while I'm doing it. So where are we? Introduction. Yeah, here. So here we go. What is this course? Well, it's 193A, Intro to Android Development. It's going to be taught by me, Marty Stepp, and I wanted to have our two TAs stand up for just a second. Darren and Gracie, please stand up and say hi. Darren, why don't you say hi, tell them who you are, tell us just a little bit about yourself.
My name's Darren. I took this course last winter and then liked it so much that I went on to go over the summer, work on the largest Android code base in the world at Facebook. And so promise this course is all you need. It's really awesome. Marty does a great job, and I'm excited to TA. If you guys have any questions, please come to me.
Hi, my name is Gracie Young. I'm a sophomore, and I also took this course last winter. And I went on to work at Qualcomm on their computer vision team, working on an Android demo app.
Yeah, thanks. We're so happy to have both of you here. This is the second time the class has ever been taught. I created the class a year ago, and I taught it by myself with no TAs, and that was lots of fun. I highly recommend teaching with no TAs and then grading all the programs yourself. That's lots of fun to do. But no, I'm really excited to have two course alumni to come back to help out with everything. They're going to be around holding office hours and answering questions and just doing a whole bunch of stuff, holding special sessions to teach you additional topics. So I'm super pumped that they're here. So anyway, what is this class all about? Well, it's Dropbox. This class is not about my Dropbox. Please close Dropbox. There we go. Sorry. This class is meant to be, my mantra for this quarter is no stress. And I want that to be your mantra as well, at least when it comes to this class. You probably have plenty of stress somewhere else, but I don't want it to come from here. That's why the class is only 1 or 2 units. I don't know, when you guys went to sign up, I don't know if you I think it let you choose like units 1 or 2, and that's up to you. If you want the 2 units, that's fine. If you only want 1 unit for some reason, I think grad students pay by the unit, so you might want to pay less or something. That's fine, whatever. I won't expect anything different of you related to how many units you're signed up for. The course is listed as being pass-fail only because basically when you have a class that's for a letter grade, it requires more work out of you and out of us to more precisely measure your performance. We would probably have to give you more rigorous work to do, and we'd have to figure out who deserves that A+ and who gets the B and the C and all that stuff. And in general, like I said, I don't want the course to be high stress. Like what I kind of want is to pass everybody as long as you do a decent amount of work. I'm not going to nitpick every little thing you mess up. I'm not going to require you to turn in every single thing. I'm not going to require you to show up to these lectures if you don't want to. So my goal is that as long as you don't just completely disappear for the next 10 weeks, then you're likely to pass this class. And I don't want you to be stressing out about how you're doing in this class or anything of that nature, right? But, oh, by the way, at any point, wave at me if you have a question or comment or something you want to interrupt me. Please do. So, anyway, we do have the 2 TAs to help out, but, there's a lot of you if you look around. Like in 106 or some of the early classes, the ratio of TA to student is a little different, right? So because there's only 2 of them and 1 of me to answer questions for all of you, that means maybe more than in something like 106, it would be expected that maybe we would try to help each other a little bit. And in 106, we give you warnings about honor codes and don't look at her code and don't copy his work and all that kind of stuff. And, I still don't want you to completely plagiarize something, like take someone else's program and copy and paste it and put your name on it and turn it in. But short of that, I want you to collaborate and talk to each other, and the collaboration that's like allowed or encouraged is a lot more in here. Like if you want to look at each other's code or talk to each other about your solution, look at this, why doesn't this work, look at my screen, look at my file, go ahead, that's fine. We're not going to be chasing you around about honor code stuff. If I feel that someone has blatantly plagiarized someone else's work, I might speak to them and say, hey, I don't feel comfortable you receiving full credit for this. But anything short of that, like even if somebody else helps you with writing your solution or whatever, like that's okay. So I don't want you guys to freak out about, I'm not allowed to help you, I'm not allowed to talk to you in this class, okay? So in terms of getting help, we're gonna have office hours posted. We're still picking our office hours. Those will go up on the website this week. But also, if you can't make it to those hours, you can contact us. Maybe you can make an appointment or something like that. But there's also other ways that you can get help. If you go to our class website, we have this Piazza forum. You guys know about Piazza, right? You can post messages there and you can ask for help. You can also email us. I would recommend using the Piazza instead of emailing if it's about course material, because that way everybody can see the question and see the answer and it'll help other people. If you have a question that's private to you about your registration information or something personal, you can email us. Either way is fine. So again, these are some of the different ways that you could ask for help if you wanted help during this class, right? And we're not going to have any homework assignment that goes out today, but when we do have homework assignments, they will be a little more open-ended. Like in 106, you get this detailed spec. In most of the courses in this department, you get a spec with lots of different requirements you have to meet, and it's pretty detailed and stuff like that. And you might find that the specs in this class are a little more open-ended, like do this or that or both, or some of this kind of stuff. The intention would be for you to have a little more space to play around, be creative, and honestly, if you go in a different direction, like if you're looking at the spec and you go, oh, I don't like that button, I'm going to make a spinning gizmo instead or whatever, as long as you do something that's pretty close to the spirit of what we're asking you to do, likely that's fine and you'll just get your credit. And I think everything's meant to be a little more relaxed and open-ended, and just we're here because we just are interested in learning about this stuff and playing with this stuff, and the intention is not to chase after you because you deviated in a small way from some rigid spec, right? So different feel to this class than 106, 107, something like that. The slide here says possible peer grading component. So I guess I should scratch out the word possible. Like that's is basically going to be something I want you all to do. Since there's not very many of us and there's a lot of you, we're going to ask you for a little bit of help in terms of helping to evaluate the work of others. It's kind of a strange thing to do. But what we're going to do is, after you turn in your assignments, we're going to contact you and say, hey, here's someone else's solution. We want you to download it and run it and try it out and see if you think that they completed it or did an acceptable job on it. We'll give you some little more detail about what we're looking for. And then you'll go to a web page where you tell us what you think, whether this person met the requirements or not. And so you'll help us evaluate each other. We're also going to double check some of it ourselves, and we'll be managing the whole process, so you don't have to worry that your grade depends on some vindictive classmate who's got it out for you or something like that. Nothing of that nature. But ultimately we will be the final arbiters of work, but we want you to help us out. So that's one of the things we'll expect out of you. Don't worry, I'm not trying to farm out hours and hours and hours of work to you. It will be a small amount of work. You know how this goes, right? You guys are my cloud computing. You're my Amazon, AWS cloud computing engine, where each of you has to do a little bit of work, but the net result is that you've done a lot to help out. So we'll talk more about that later because there's nothing to do for that yet. And like I said here, this is meant to be a little vague, but as long as you submit something that represents a noticeable amount of effort, on most of the assignments I gave you, we will, as long as you do that, we will pass you. So I'm not being super specific, like you have to turn in exactly this many or whatever, but it's meant to be pretty lenient. Last time I taught the course, I only failed one person, and that was because I never got anything from that person. Like, he didn't turn in anything. And everybody else seemed to at least submit most of the work, and they didn't necessarily finish everything, but they showed me that they were doing something. They were trying to do something on each assignment. They all passed. So again, like, that's part of the no stress Marty Step 193A mantra here, right? Any questions so far about any of that general stuff, like about what we're going for here? Yeah.
Sharing code and ideas and stuff, I guess, obviously is more open than the other CS courses. But if we run into a bug or something, should we throw up our code on Piazza, or is that offered?
You can totally put your code on Piazza. That's fine. I mean, I would be a little reluctant if you took your whole solution and said, here, everybody, lol, here's the solution to homework 2. But like, if you say, hey, I've got this little chunk here. I don't understand why on this line I get a null pointer. Can somebody help me, paste? Fine, do it. No problem. And you other guys who would see that code, you might say, oh no, I can't look at that because that's bad or whatever. You can look at that. I don't care. I mean, I would advise you not to take large chunks of someone else's work and just paste it into your solution. But I want you to generally feel like it's okay. They're not going to come chasing after me for this. I think the one thing I want you to absolutely avoid is like, hey, send me your solution. I'm going to change your name to my name and I'm going to turn it in. Don't do that. But short of that, I think almost anything else is fine, okay? And like in 106 lately, we've been doing some like pair programming where you can work as a pair and stuff like that. And we're not going to have a pair programming process here. So I want everybody to turn in their own submission. But if you basically worked in a pair and you sat with somebody and you both kind of worked along and you collaborated a lot along the way and your solutions look pretty darn similar because of that, that's fine. So you basically pair programmed. I just want both of you to turn it in. As long as it's not literally the same file with the name changed, then that's fine. Okay? Yeah, good question. Any other questions so far? Well, bottom of the slide here talks about prerequisite. Like, what do I expect? What do we expect from you? Well, the goal here is not to expect that much prerequisite knowledge out of you. I mean, I want you to know how to program, so like you should have had 106A and preferably 106B. It says here basic Java knowledge. Now, I know that some of you don't know very much Java. Maybe you skipped 106A, you went to X or something like that. So I know some of you are not super sharp on Java. And the TAs and I are working on, we're going to probably do like a Java review session late this week or maybe early next week for those of you who are just like, whoa, I haven't seen Java before. I'm going to mostly present as though you took 106A here and you know Java, but maybe you're a little rusty. Like maybe it's been a year, 6 months. You kind of forget some of the details, but you've seen things before. And if I show them to you, you'll sort of quickly remember them or you'll make a note of what was that. I better go Google that. Like that's kind of the way I'm going to present to you. So if you want a Java refresher, we're going to try to offer one for you. Although generally speaking, going forward, we're going to sort of assume that you have a basic knowledge of Java. Okay? Because all the code we write is going to be Java code, so that's important. Yeah, and I don't really expect that much else. I mean, we're going to talk about data structures a little bit, like maybe we'll want to make an array list, which is like a vector in C++. We might want to make a hash map to store some data in, but that's kind of it, just variables and functions and parameters and loops and arrays and maps and just these kind of basic things from 106 level stuff. That's kind of what I expect. Now, some of you guys are way further than that. Some of you are seniors and grad students and stuff. We admitted a broad range of people. So, don't be surprised if the person next to you has a very different level of experience than you have. That's okay. Well, the class can still benefit people of different levels. But my target and my expectations are kind of, this is all I want to force you to know, Okay, so, yeah. And if you want to look at some Java stuff ahead of time, like even in advance of our TA-led Java session, I do have some slides. If you go to our webpage, 193a.stanford, if you go to lectures, and I don't know if my internet connection is working. If you go to today's lecture, I posted a deck of slides called Java Review. So you can just skim through those and say like, oh, do I know this stuff or not? Like that would be a place to start. I went through this last year and made most of this. I put the stuff in there that I thought you would want to know for this class. Okay? So yeah, that's what I expect out of you. Okay, so yeah, I guess that's most of the, let me see if there's any other course policies or something from this handout. These are where the lectures are, Tuesdays and Thursdays. Last time I taught the class, it was only once a week, so I'm kind of looking forward to having 2 lectures a week because it'll give me more time to show the different topics each time. Last year when I taught the class, it was really hard because I only got 1 presentation a week and I had to finish everything on that topic. And I didn't get to see the students again for a whole week, and I think everybody kind of forgot. By the next lecture, we all forgot what happened in the last lecture. So I think this will be more conducive to actually learning anything to have 2 of these. You never have to come. I think I said that. Lecture attendance, optional. People always ask, are we going to record the lectures? And in general, no, but I'm trying something today. I have this program where you can record the screen, and it also records the microphone built into the... basically, I'm currently making a piece of shit recording of this lecture. But I do not promise that it will be watchable or that you'll be able to hear anything or that I'll even have it, because I don't even know if it'll work. When I click save at the end of a class, it might say the file's too big, save failed. And if it failed, then tough. I'm not going to do anything about that. So I'm going to try to see if it'll let me record lecture today. And if it works, I'll keep trying to do it. But no promises. So in general, if you ask me if lectures are recorded, I'll say no. But you know what I really mean. If this works, I'll post it on YouTube or something. But we'll see. I'm no guarantee that it will work. I only tried it for 2 minutes of recording, and it worked for that. So I extrapolate that it will work for 70 minutes. What else? Oh, good news. There's no tests or quizzes of any kind. No exam, no final. That's all part of the Marty Step, no stress package that we offer here in 193A. All you got to do is turn in most of the little homework projects that I give you. And I realize this is a 2-unit course. I'll bet a lot of you have taken a course that was 1 or 2 units, and the fucker who was teaching it gave you like 10 units worth of work, right? That's not me. At least I will try very hard to make sure that that won't be me for this class. So what I'm going to do is when I give you a homework project, there will be a sort of basic thing that I want you to do. And my goal will be that you should be able to do that in a reasonable sitting. I know how many units you're assigned up for, 1 or 2. I'm targeting 2, but like I'm going to assume you're going to sit down and work for a few hours. And then if you work that much and you get this certain minimal amount done, you can just stop and turn that in. Or even if you're not quite done with that part, you can kind of stop. Once you feel like, hey, I put in the time I should have to put in for a 2-unit class, you can kind of turn in what you have, and that'll probably be good enough for me. Then there will be some other stuff on the homework spec. If you got into this and you want to do a little more, here's some extra stuff you could add, some more features and some more stuff you can explore. Optional stuff. If you want to turn in a really awesome, kick-ass solution with a bunch of extra features, sure, go nuts. Or if this week you've got projects due, you got midterms, just kind of give me the minimum bar, turn it in, and move on. Like that's kind of how I'm going to do everything. And that's all you have to do to earn your pass grade for the class is just submit most of those things. Okay? We are not going to accept late work, though, because we keep moving. We want to move on. And I think the goal here is you should be able to just give me something by the due date. Just whip something together and turn it in. If you can't get it done, just skip that one and do the next one. You could probably skip an assignment or 2 and still pass, but don't skip all of them. Okay, I think that's it. I'm not going to talk more about homework and grading and turning in because we're still working on some of that. We're going to try to set up some version control stuff where you can turn in your project and keep your projects stored in a repository in kind of a simple way, but we're not totally finished setting it up. So I'll talk more about that probably Thursday. So I think that's all I want to say about like class policies and just what the class is. One more time, is there any other question about kind of about the class?
I saw that there, like Android tablets are like useful but not necessary.
Oh, that's a great question. Thanks. Like, should you own an Android device?
Yeah.
Not required.
Okay.
I'll show you in a few minutes. Like, you can run an emulator version of a fake device on your computer, and you can test all your projects on that, and that's fine. And actually, that's how I do most of my testing when I write my homeworks and my projects. It is a little flat if you never get to really see it on a real screen ever, so it can be fun to have the device to plug in. And the emulator is slow and it eats a lot of RAM and it slows your CPU down a little bit. So sometimes it's nice to just have the real device plugged in and then when you compile, have it run on there, so it makes your computer not go as sluggish and stuff. It can be more pleasant to develop that way or test that way, but not required at all. Like if you're an iPhone person and you don't have any Android devices, fine. If you want to buy a device just for developing on, now or later, there are some links in the link page here that I think are cheap, reasonable quality devices. Both, I don't think I have any phones listed because phones are usually like $800 because you don't have a contract or whatever, but tablets, there's some pretty cheap tablets that you can buy, even as low as like 30, 40, 50 bucks. You could just get a cheap, dumpy tablet that actually is good enough to test on. So if you're interested in that, I've got some links on that for you. And if you do have a phone or a tablet or some other kind of Android device, you can use it. You might wonder, like, if I use my real phone, am I going to brick my phone or mess it up or something? And no, you won't. It's fine. Like, there's no reason to avoid playing with your real phone. So you don't need to buy like another phone or something like that. Yeah, good question. Any other questions so far? Okay. Oh, I was supposed to tell you. I was supposed to tell you a little bit about myself. If you don't know me, it's my third year here as a lecturer at Stanford. I used to live in Seattle for about a decade before that. I worked for Microsoft for a while. I taught for University of Washington for a while. That's where I met my now wife, who I married and moved here with, and we got 2 puppies this past summer. Yeah, so last year was a pretty awesome year for me. I got a lovely wife and 2 lovely pooches, and I don't know, I thought I was having a bad week because, I got to go back to work, got to go back to school, but the pups had a worse week. They got snipped at the vet, so they're wearing little cones on their heads right now, poor guys, but it gets better. If you want to see lots of dog pictures, you can be my Facebook friend, so think about that after class. And I brought my favorite Christmas present to class. The Kylo Ren lightsaber. My wife knows me well, and she chose wisely. It doesn't actually kill anything, but pretty awesome. So yeah, I hope you guys had a good break. I won't spoil Force Awakens during class today, I promise. Yeah. Anyway, no, it's good to see all you guys, and I think we're going to have fun. Like, the goal here is we're going to have fun. We're trying to learn Android and do some cool stuff, and hopefully it'll be an enjoyable class, and hopefully low stress, right? Okay, well, that's what the class is. That's who I am, and let's talk about Android a little bit. I don't have a clock. Is there a clock in here somewhere? I just don't want to run out of time. Maybe I'll get my Android phone out to be my clock. So what's Android? I think it's an operating system that runs on phones that is maintained by Google. Google didn't create Android at first. Another company made it, and Google bought them. But Google has run Android for many years now, and so that's their OS at this point. Runs on lots of different devices, right? Phones and tablets, I think, are the first 2 that come to mind. But now they have these watches called Android Wear. I happen to own an Android Wear watch. I don't particularly recommend them if you're thinking about buying one. They're not very good. You can run Android on a TV. There's all kind of different devices that run Android nowadays. It's mostly, in terms of development, it's based on Java. I think I mentioned that earlier. So if you're going to write apps for Android, you basically write Java. And the underlying operating system underneath is based on a version of Linux. So that's kind of interesting. Android, in terms of number of devices, is the world's #1 operating system, which kind of blows my mind, really. You think it'd be like Windows 10 or Mac OS or something, but there's just so many phones, that Android is the world's #1 OS. So it makes sense that we should learn to write apps for it, right? There's a ton of apps that already exist that you can go get on the Play Store, over 1 million, I guess, nowadays. And Android itself is open source for the most part. Every couple of releases, they dump the whole OS source code out in case people want to go download it and look at it and modify it. So that's kind of interesting. Why should you write Android apps? Well, you probably already want to because you're here, but I just want to make sure we have some motivation here. Some people say, well, I don't want to write a mobile app because you could just make a web page, and on the phone you can open the web browser and you can go to the web page, so that's fine. Why should I write an app, right? Well, a lot of studies indicate that mobile users hate using the browser. They want to open apps and they don't want to spend time in the browser for a lot of reasons. I mean, you guys have phones and tablets, right? What's it like when you use the browser on the phone in general? Like what are some things that can be bad about that experience? What do you think? It's slow? Yeah? What else? Yeah, it's all mushed. It doesn't align properly. You have to scroll to the side and up and down. It doesn't seem to fit. It just doesn't look like whoever built the thing had you in mind when you're using it on the phone. Anything else you can think of that's bad about web on the phone? Yeah.
Doesn't work if you don't have internet.
Right. Sometimes apps work even if you're offline. Not all of them, but a lot of them. And a website, for sure, you have to be online to use it. Although new web technology is coming to make that a little better. But for now, yes, absolutely. Doesn't work if you're offline. Yeah, there's a lot of different, you can probably think of some other disadvantages. I put a screenshot, it's kind of hard to see what I'm getting at here. I put a screenshot of a mobile web page of Facebook, I think, or no, that's Facebook, yeah. And then on the right is the actual app. And I think the purpose of those side-by-side screenshots is just to show you, like on the left one, the web browser one, there's like this big address bar that's kind of wasted space. I don't really want to see that. And then not everything fits quite right, and it has awkward scroll things on the top and the bottom. And basically, you have more control. There's other stuff that you guys didn't mention, which is like if you write an app instead of a website, you can fully access all the different hardware. Like if there's a camera, you can use it to take a picture or something. If there's a microphone, you can listen or record or whatever. And on a website, you often cannot do that as easily. So there's a whole bunch of reasons why you would want to make an app instead of just a web page. Okay, I think that raises another question, which is why make an Android app and why not make an Apple app for the iPhones, right? Well, for starters, there's nothing wrong with making iPhone apps. You go ahead and make an iPhone app if you want. There's a whole class for that called 193P. And, you know, if you want my honest opinion, it's probably a better class than this one by a large margin. Because they've been teaching that for a while and they really know what they're doing and they've got their whole system up and running. They've got a very strong course. And so if you take this and you're still interested in mobile, go take that. I don't think the two are redundant. There is some overlap. You'll see a few common things, but it's a very different class than this. And they do a good job in their class. So I'm not saying anything bad about writing iPhone apps. It is a little different. One thing I like about teaching this is that it's Java. If you do apps for iPhone, you use this language called Swift, or if you write an older app, you used a language called Objective-C. And there's nothing wrong with those languages, but we don't know them, and so I would have to teach you the language as we went along. So it's nice to have a language of Java that you mostly are already familiar with. Another thing that's different is, you know, all the stuff you'll need to develop Android apps is totally free for everyone. And depending on who you are and what you're doing, sometimes you have to pay money for the development tools on iPhone development. Sometimes you don't, but sometimes you do. And also there is a difference between once you've written the app, how do you publish it and get it onto the other people's phones, like your dad's phone or your friend's phone, or put it in the App Store for everyone to play with. It's a little bit harder to do that on an Apple device than Android. So yeah. Anyway, they're both fine. There's nothing wrong with iPhone development, but that's not what we're going to cover here. In fact, I don't know anything about iPhone app development. So if you try to ask me, is this kind of like that on the iPhone? I will say, maybe, because I don't know. Darren might know, or Gracie might know the answer to that. But I don't know anything about Apple development. The only thing I know is that I won't be doing it anytime soon. So, okay. Android, what is there in Android? Well, it's an operating system in the same way that Windows is, or Linux is, or Apple iOS is. It provides a bunch of libraries and systems to help you interact with the phone and interact with other applications or hardware and software on the phone. It's got a whole bunch of different pieces. This picture is kind of meaningless. It's just got a bunch of bubbles on it and stuff. But I guess I'm just trying to show you that there's a whole bunch of different components of Android. You can use the Android OS to make phone calls. You can use it to pop up other programs like a contact list or a browser, all kinds of different things. You can use it to connect to the network, connect to the internet, connect to other phones. You can use it to access hardware like cameras and microphones. It has a bunch of graphics stuff if you want to draw shapes and three-dimensional stuff. It's got a whole bunch of things built in if you want to play audio. It's all kind of packed in there into the Android operating system. we're not going to learn the guts of how it all works under the hood. We're just going to learn what's available for us to run and talk to. Now, if you know your Java, you know that you'll write a source file that ends with .java file extension. And then when you compile it, what kind of file do you get? Remember? When you compile a Java program, you get a dot what? Okay, I got 3 interesting answers. I heard jar, I heard APK, and I heard class. And depending on context, each of those can be right. What I wanted was .class because that's the compiled binary bytecode version of the Java file. When you said jar, a jar is a collection of class files in a container. APK is also that. So basically, you compile it and you get these class files. We'll come back to compiling and running apps a little bit later. Android has had lots of different versions come out over the years, and here's a quick timeline of the different versions that have come out. If you've got an Android device with you, I'll tell you how to check what version you have in just a minute. Now, last time I taught the course a year ago, the current version was called Lollipop. It was 5.0. And as of a few months ago, version 6 came out. It's called Marshmallow. So you'll notice right away that all the different versions have these code names, right, that are sweets, desserts. And you might also notice something else about the sequence of names. What else is interesting about the pattern? Yeah? It's alphabetical order, right? Like F, G, H, I, J, K, L, M. So what's a good treat for N? How about Nutter Butters? Something like that. Anyway, they're going to have, the next one's going to start with N, and so on. So yeah, so if you look at the chart, they'll sort of put out a release once every year or so, right, of a new version of Android. New version is version 6. So you might wonder, what version are we going to learn in this class? What version are we going to target? What are the differences of the various versions? Well, let's talk about Android versions for a minute. I think it's an interesting question. If you look at all the phones out there in the world, what version of Android are they running? Here's a chart. It's a little hard to read the chart, but here's how I would read it. If you look from over here, this is right now, December 2015. If you go up the axis, the y-axis here, if you stop at some point, like here, 50%, and then you look down from there, 50%, what is this, 66% of users are running Android 4.4 or newer. That's the way to interpret that. And then the greens are earlier Android 4s. 4.1 is way up there at 93%. You see that? So I guess what I'm saying is if you say, I'm going to write an app, and I'm going to target Android version 5.1. So you have to have at least 5.1 on your phone for my app to work. If you decide that, your app will only work on 12% of phones. So that's stupid. Don't do that. I mean, over time, this graph moves as phones update, right? You ever get your phone download a new version of the operating system, whether it's an iPhone or an Android phone, you'll sometimes see that kind of message will pop up. So over time, the phones update, right? But as of right now, if you write an app, I think most people want their app to run on as many phones as possible for the most part. If you want to reach all the phones, if you look at that bluish one that goes almost all the way to the top, that's gingerbread Android, which is 2.3. So if you really wanted your app to work for basically every phone that's actively being used on the planet, you could target that. But that's old enough that I'm going to punt on that. And so for this class, the stuff I'm going to show you, the stuff we're going to talk about, is going to be Android 4 and up. So the stuff we learn is going to run on pretty much every phone, except for a couple of clunkers in Uzbekistan or whatever that haven't updated, or someplace. Most anybody's phone around here is going to have version 4 or 5 of Android. And you might worry about what's the balance between am I learning out-of-date stuff? And I guess what I'll say is no, not really. The core of Android, the basic stuff, hasn't changed very much since version 4. But if you keep going back far enough, it starts looking different. I don't want to talk about some of the really, really old stuff. But there's not a lot of stuff from 6 that we will care about. So it's not really a big deal for us to target sort of here. We'll reach everybody without learning out-of-date things. That's kind of the sweet spot, I think. Okay? So that's what we're going to do. Okay, so versions of Android. If you want to know what version, if you have an Android device and you want to know what version of the OS it's running, this is usually how you do it. You go to your settings, you go to System, you go to About This Device, and somewhere in there it'll say Android version. So you can check, and see what you're running. My phone not so long ago updated to 5.0. This is a Samsung Galaxy S4 that I got through AT&T. So why is my phone running 5.0 and not 6.0? 6.0 came out in October. You would think that by now my phone would have pulled it and downloaded it and installed it or something, or at least asked me if I wanted to do that. Unfortunately, there is a series of blockades in the way that might stop that from happening. Google puts out the new version of Android, and then your phone provider has to download that new version and pack that up into a way that will install on your phone. And then on top of that, your cell phone company has to pull that and set up a version of that that'll connect to the AT&T towers, and then they have to push that to you. So if either one of these two companies is lazy and doesn't do their part, you never get that update. So your phone gets stuck. The new bytes are back here, and they're not reaching you. Sometimes even Samsung updates for the whatever Galaxy, and then AT&T says, we're trying to phase out that phone. This is an older phone. It's 2 years old. We want you to update to a new phone. So we're not going to release the new Android for you. Instead, come in and sign up for a new contract and get a new phone, and we'll throw away this old clunker. So there's a lot of reasons why phones don't have the newest Android. Even if the user understands and wants to update, it might not be possible for them to do that. This is one of the biggest flaws of Android. And Google, I think, traded, like Apple has more control over their platform. When a new version of Apple iOS comes out, they basically have the ability to push that to most of the phones. I bet most of you guys who have iPhones have the pretty much newest iPhone app OS versions and stuff. When Google made Android, they really wanted to maximize usage by lots of different providers and lots of different phones and lots of different people. So in order to achieve that, they sort of let go control. And they said, we'll let you guys customize how it gets installed and all this. And that's part of the reason why Android is so heavily adopted by all these different phone makers and stuff. But the price of that is that Google can't just push all the bits to you when they're ready. They're trying to fix that. They're working on that. But as of now, this is kind of how things go. And actually, let me check my phone real quick. This is the only class where it's totally acceptable to be goofing around on your phone during class, right? It might be class related. So let's see, my device, or it might not be class related. About device, what do I have? Android version 5.0.1. So I'm here. I'm in here. So there's a few newer versions that I don't have yet for me. And I don't know if they'll ever put out for this because this is getting old. It's like a couple years old phone. Santa brought me a lightsaber instead of a Galaxy phone this year. So, okay. Well, anyway, how do you write Android apps? That was all kind of background about the OS and the ecosystem. You don't have to worry about that stuff very much during this class or anything. I just wanted you to know about it. So how do you write Android apps? Well, you need to download a piece of software called Android Studio. So that's another thing. I said if you only take away one thing from class today, you should write down the class website. But kind of the other thing that I think you ought to do is go download this. There's a link to do that on the class webpage under Android Studio at the top bar. Click it. It has instructions what to do. You need to install Java, JDK if you don't have it already. And you need to install this Android Studio editor. And there's a couple other things you have to click. This webpage will tell you what you have to do. Go try to set that up. Non-trivial number of people get stuck on this for some reason or another, and they need one of us to help get it working on your laptop. So that would be a good thing to try to do between now and Thursday, so you can ask for help if you get stuck. So it's based on an editor. This Android Studio editor is basically a rebranded version of another piece of software called IntelliJ IDEA, which is kind of a general purpose Java editor. Google took that and kind of slapped on some Android stuff, and now they call it Android Studio. But that's okay. That's fine because IntelliJ IDEA is actually a very good Java editor, so it's fine that we would use it. It's free. Go download it. Go set it up. I've got it running on my computer already, and I'm going to play with it. We're going to write some code in a minute. I'll talk more about the editor in a second. Okay. When you make a project, we're going to start getting into the details in a second here. When you make a project, there's different pieces. I'm not going to go into much detail about this yet. We'll come back to it throughout the quarter. But there are some various files that contain settings and information about your project. Android projects use this format called XML. You guys know about XML? You ever heard of that? You know what that is? Like, what's XML? It's a markup language? Okay, what's that? Yep.
Like a web interpreter in your document has this, it's like HTML is to web pages, XML is sort of like a database backend.
Yeah.
But then like putting code or document and then like marks it up so the computer knows what it actually is.
Yeah, it's a syntax for marking up data in a text file, and it looks very much like HTML. So if you've ever written a web page or looked at the source code, the HTML source code of a web page, XML looks about like that. We'll look at it in a minute. We will do a little bit of manipulation of XML data in this course, although most of our development is Java. So there's these various different folders that have files in them. There's a source folder that contains Java classes. That's the Java code that we're going to write. Will go in there. There's also a folder called res, which stands for resources. And inside there is a bunch of subdirectories. Every project can have these different resources that it uses. You could put images in a folder called drawable. You can put in menus and styling data and a bunch of other things inside this resource folder. I'll show you what's up with that as we go along. Android projects also use a separate system for compiling and bundling them up and putting them on your device. That system for compiling and managing the project is called Gradle. It's like if you know what a make file is or a build system, it's like that. This is something that happens internally that you don't usually have to worry about, but it's there. It's part of the system. So anyway, okay. The other thing that comes into play when you're doing your development is you probably have a virtual device, which is a fake phone or a fake tablet that runs on your computer as an emulator. They call it an Android Virtual Device, AVD. So you asked about whether you should have a device. You could just use this instead. And I'll show you in a minute, when you click run, you can tell it to launch a virtual device and you can test your little app on here. It runs a little bit slowly, especially if you have an older computer. My laptop, just like my phone, is getting a little old, so I should probably update both of them. On a newer computer, it's pretty acceptable speed. Anyway, you don't have to run this virtual device. You can run your app. You can connect a USB cord to the computer, and you can actually have it build your project and send it straight into your phone and run it on your phone to test it. That's a little more pleasant, a little faster for some users, but this is easier to set up, I think. So when you do your installation, like when you go to the class website and you go through this set of steps here, one of the steps is going to be how to set up the virtual device on your machine. You actually have to tell it like what sort of a device you want and what properties it has. And the directions talk about that a little bit. Okay, so that's not the end of class, but that's kind of the background about Android as a whole. So in terms of the slides for today, all the slides are posted ahead of class, by the way. So I talked about my introduction. Now I'm going to talk about making our first app. Okay, so let me open my first app slides. First app. And I was really tempted, when, the old practice, right? When you make a first app, a first program in a language, what are you supposed to make the program do? You're supposed to make it print hello world, right? Okay, well, so we don't really do that on a phone, right? Because it's a visual, graphical, so printing hello world would be kind of boring. And I thought, what's the equivalent to that for a mobile phone? What's the first basic, simplest app that the user would really want? And I thought, oh, I know. It's an app with a button. When you push a button, it makes a fart sound. It's a fart app, right? And I thought, no, I can't do that as a first app. So maybe we'll do that another time. But it's an interesting question. What's the equivalent of hello world for a phone, right? But okay, how do you create an app? Well, let's start with a goal. We'll see if we can finish this app in class today. When is lecture at? 2:50? Is that true? 1:30 to 2:50? Okay. Goal is maybe we can try to write this. It's a number guessing app. There will be two buttons, and they'll both have numbers on them. And the user's job is to push the button that has the bigger number on it. And if they do that successfully, they'll get a point. And if they push the button that has the smaller number on it, they'll lose a point. This is AKA the Berkeley admissions app. But I just wanted to come up with something really simple, but where it had to have a little bit of behavior and a little bit of stuff going on so we could build something, right? So let's talk about all the stuff we would need to know to do this. We need to know how to put things on the screen, and we need to know how to respond to events. You guys may remember if you took 106A that when you click a button or something, that's called an event. you can write code that will react to an event, respond to an event, and run some code to handle it. Okay, so let's go through some stuff. Let's make a new project. So if you go to Android Studio, the main menu looks kind of like this, and you say, I want to start a new project. And I'm going to call this Berkeley Guessing Game. Okay? And I'm going to say, I don't know why some of the stuff on the screen is kind of missing here. I don't know. I'm going to click Next. And it's asking me a few questions, and I don't know why, but the screen is kind of messed up. It's not showing. It's something about the projection or something. But basically, once you type in the name of the project, you can just say next, 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 finish. It should be fine. It's asking me, do I want to work on a phone or a TV or a car? Ooh, Android Auto. Let's do it. So it asks me, what do I want? I'll say I want basically let's do an empty activity. Let's do that. Okay, finish. So I'm just saying next, 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 finish, basically. And I get an empty app, I hope. Building Berkeley Guessing Game. One thing you'll see is that it's a little slow to get some of it set up, especially the time that it takes to launch your little emulated virtual phone is really slow. It takes like 10 to 30 seconds to load the stupid thing. It's like booting up a little fake computer, So a lot of times if you boot it up and you have the phone running, when you're done playing with it, you don't close it, you just leave it, and then you write some new code and you recompile it and rerun it, and it'll put it on the new phone again. You don't want to close the phone and make it relaunch the phone every time. That'd be really slow. So I have an app here with nothing in it, and I think I can just run it. I'm pretty sure there's this play button that means run. So I'm just going to click that, and it's going to ask me what device I want to run the app on. And if I had a phone plugged in, it would list it up here. I could say, put it on this phone, but I don't. So it says I want to launch the emulator. I've got some different devices. I've got a couple of them here. The instructions of how to set up talk about setting up these virtual devices. I've got two. I've got one that's a phone and one that's a fake tablet, just because I wanted to try the difference between. I'm going to run it on my fake phone, which is called Nexus 5. So I'll say OK. And it runs. This is the part where I have to wait for the emulator to launch. You'll see a window pop up. This is also the part where you'll wish that I had a faster computer. So a lot of lectures, I'll just launch this before class, but I wanted to do it live this time. So you'll actually see it'll look like the phone is booting up. You'll see the little Android OS logo and stuff like that eventually. Also, if you're in the front rows, you can hear my fan on my laptop going nuts because it's like slowed. It's running as fast as it can. Come on, little device. You could see why some people plug the real phone in, because they wouldn't have to load all that up every time. Okay, so, it's charging. Oh, that's good. Uh-oh. My battery's only at 50%. I better charge more. So, hooray. It launched, and it says Hello World. So they put Hello World on the screen for me to start up. Now, like I said, don't close that window. That long wait that I just had was to launch this window. I can leave it up and just don't look at it if I want to edit the code. Okay, so I made a project. Let's go back to the slides. Now, here's some terms. There are going to be a whole bunch of terms in this course, and a screen, the basic unit of an app is called an activity. Activity is like a synonym for a screen. A screen with some buttons on it, and if you click a button, maybe you jump to a different screen. You'll start seeing, as you learn some of this stuff, you'll see how those concepts appear in actual apps. On the Facebook app, when I click this, it jumps to another activity. Oh, I see. You'll kind of start thinking of it that way. So an activity is a screen of UI to work with. Each individual thing on the screen is called a view. That's like a general term, like a button is a view, and a text box is a view, and any little different thing can be called a view. Views can also be used for laying out controls on the screen in different positions, like in a grid or in a row or these kind of things. We have events, like when you interact with a widget by clicking on it, by typing on it, by sliding your finger, whatever, that's called an event. There's some different things that appear on the screen. Some apps have these action bars of things at the top, of things you can do, like kind of a menu. We're not going to have that right away. There's this top right with all the little icons, like when you have new messages or the icon that shows your battery. That's called the notification area. So there's some stuff. There's different things on the screen. We're not going to do all that right now, but there's different stuff in Android terminology here. Okay, so here are some of the different views, some of the different widgets that you could put in an app. I think some of them are really self-explanatory, like there's buttons, and there's text you can put on the screen, and there's checkboxes. Like a lot of that stuff makes sense. Some of these things are a little more esoteric, but we'll use most of these during the course here. Okay, that's not all. That's a subset of the ones available. So if you want to make a user interface, there's a lot of stuff I want to teach you about this. There's like laying out things and making it look just right, and there's a whole bunch. We're going to talk a lot about it. But if you're a noob, there is a nice little visual way of creating a quick and dirty user interface for an app. And that's what I'm going to show you today. So if you go back to your project, it puts me into this activity Java code, and I'll talk about that in a sec. But it also opens this thing called activity main.xml. I talked about XML, that's a syntax that looks like HTML or whatever. If I click on this, then I get, I will get in a second, I get a picture of what the screen for the app looks like, and then I have this XML content here, which is the stuff that looks like HTML. They have this really nice little tab at the bottom that says Design. If I click on this Design tab, I am sent into a screen where all the little widgets are over here, and I can just drag them and drop them on the screen, and I can like build my UI without even really understanding any of the programming for now. So here's some stuff I'll do. I'm going to click this thing that says Hello World, and I'm going to press Delete. Get rid of that thing. I want to try to make the screen look like my example. Where is it? Back a few slides. I'm going to try to make it look like this. Okay? So let's try it. It says the bigger number game at the top. So what is that? Well, if you look at this screen, it's a piece of text. It's called a text view. If I want to be able to type on it and edit that text, I make a separate thing called an edit text instead of a text view. So I come over to here, and I just find plain text view. Okay, I drag it, and I drop it, and it has these little guiders. Like it seems to like kind of snap to the edges and stuff. It's giving me some little hints about a line top, all this stuff. I'm kind of just going to wave my hands and say that's called layout. I'm going to talk about it in more detail later. For now, I'm just going to kind of drag and drop things until I like the way that it looks. I'm going to let go. So I drag that to the top. And now I've got a little text box. You can't really read the text because it's so small. But over here on the right, there's a bunch of properties of this thing. Now, you could get a little overwhelmed because there's a lot of them, but you just sort of want to learn where are the ones that I care about. In fact, the editor is nice enough to bold some of them that it thinks are more important than others. If you want a text view to say some particular text, you just scroll down. There's an attribute here called text. So right now it says new text. So I think it was supposed to say number guessing game exclamation mark. I press enter, and now it says that over here. See that? It's small, but it says that. So you can like build your UI just by dragging and fiddling with this viewer here. I think on my example screen, it's bigger. It says bigger number, whatever. It said bigger number game. The font is larger. So I mean, we could play with this. Like if you want the larger font, I think that's called text size or font size. Text size. I think I could say like 32-point font. That's too big. How about a 20-point font? How about a 16-point font? Now, there's some stuff you can do, like where you can say, well, make it the right size for your device. I'll talk about it later. You can fiddle with the fonts for now a little bit. Now there's another piece of text where it says, press the button of the larger number. If you get it, you'll earn a point. So, okay, I could grab another text view. You might imagine that it would all be in the same view, but if you want different fonts for different parts, you sort of want to split it up. So here for the text, I'll say, press the number press the button for the larger number, and you'll earn a point. Earn 5 points, and Berkeley will admit you, whatever. So there, now I've got that text on the screen, just whatever the text should be. In the picture and the slide, I've got 2 buttons here. So I'll just drag and drop those real quick. So here it says button. So I drag, and I kind of want to lock it to the kind of the mid-left there. See that? There. Let go. And now it says button, new button. So I'll scroll down here to the text on the button, and I'll just, right now I'll put 0, because I think each time you play this little game, it'll pick a number to put on those. So I'll grab another button, and I'll drag him over, and I'll drop him to the align to the right. And there we go. That seems right. And then I'll set his text to be 0 also. Okay, so you see kind of how this is going. And then at the bottom, it says points 0, like maybe this will show how many points you've earned. So maybe I'll come back here and I'll grab one more text view and I'll try to lock him into the, do you see what it's doing? It's like, do you want to line up to the right side of that, the left side of that button, or it's trying to align relative to other things. And so I'll tell it align to the bottom middle basically there, and I'll say text points 0 there. Okay, so that's pretty much the UI. If I go ahead and click run, I still have that emulator going with the old version of the app. If I click run again, it'll say, do you still want to run it on this running device? I could say always use this device. I could do that. So I'll run it again. It'll take a few seconds to recompile it, and then you'll see the emulator will kind of refresh with the new state of the app, hopefully. Occasionally the emulator starts freaking out on you, but yay, so now I have a number guessing game, the Berkeley game. And if I click, you can kind of see it makes a little splash like as though I tapped it with my finger, but the buttons don't do anything. Okay? So far so good. Any questions so far? This isn't really very fair to the Berkeley people. Obviously, it's not quite that easy to get into Berkeley. They require a score of 8, not 5. It's not, okay, well, anyway, we've got stuff on the screen. We use this design view. See that bottom left tab that says design? We clicked on that so that we could drag and drop our little widgets. So we're getting a good start here. Okay, so now let's talk about when I click the buttons, I want it to actually do something. That's called an event. So how do you do events? Well, just remember, let's talk about what events are for a second. It could be a click, it could be typing characters, it could be a certain amount of time, like a timer will tick and that generates an event. It could be like when a message arrives over the network. It could be a photo gets taken on the camera. It could be all kinds of different things. It basically just represents some sort of user action or general kind of an action that has occurred that you can say in your code that you want to be notified about those actions and you want to respond to them in some way. Sometimes called listening for events or handling events, okay? And programs, Android programs are, we would call them event-driven programs. Like the overall execution of the app is dictated by the events that occur. You click this and I'll run that code. You then click that and I'll run that code. You're probably more used to an app that has a main function, main method, and the program starts there and it runs forward from there, line by line. You kind of have to let go of that model here. There's no main. You don't write a main here anywhere. Or there is probably a main somewhere, but it's like in the Android device or some other layer that you aren't writing. Main sort of is not a thing we do. The app launches and then the execution just sits there. Nothing particularly runs until the user kickstarts that by clicking on something, okay? That's called an event-driven program. Basically, graphical user interface programs are usually event-driven. Now, if you want to have events that your app will respond to, you have to write methods that will get executed, and then you have to tell the GUI, when they click this, run that method. When they type that, run that method. So you have to kind of link actions to methods, okay? So let me show you how to do that. In the view, the design view, where we've been editing our GUI, there is a property for these buttons that's called onClick. If you've ever done any web programming, that's a name that's used there as well. OnClick, that means on the occurrence of a click, when a click happens, what do you want to do? So find that property in the design viewer and type in an identifier there. You're typing in what will be the name of a method. So type that in. We haven't written that method yet, but you type in the name that you want to give to this method. And then once you've typed it in, there's a light bulb thing that will create the method for you, and then we can write the code for the method. So let me show you what I think just a demonstration is the best way to show you this. So we go back here, not the emulator, but the developer, the IDE thing. So I click on this button. I want to make it do something when they click it. Okay, well here, if I scroll through this list of properties, there's one called onClick. So maybe here I will say left button click. That's the name that I want this method to have. And I press enter. So it says, okay, you want it to run this method when they click that button. Then over here, I'll say onClick and I'll write right button click. Now notice I just write the name of the method. I don't write parentheses, semicolon. I just write the name. That's it. Okay, that's the first step. Now the second step is you have to go to this text view. See how I'm in design view on the bottom left? Turns out this designer view where you're dragging and dropping stuff is just a fancy graphical way of modifying the contents of this XML document. Everything that I do when I drag and drop leads to some sort of new content appearing in this. And the content of this is what really drives the look of the app. So, for example, it says we have a text view that says number guessing game, whose font size is 14 point. That was that guy up here. In fact, as I'm clicking on this, that element is highlighted up here. Then below that, there's another text view that says press the button to do whatever. And some of this, so basically that visual editor is, we could have typed all that out here if we knew what to type, and it would have had exactly the same effect. The visual design version is kind of just the noob version of just typing it out, basically, okay? So we have all these different things. I'm not going to totally go into what all these different things mean right now, but it's clear that these little things correspond to the widgets on the screen here. There's one for this button, and there's one for that button. See how it's highlighting it? And then there's one for this text view at the bottom. Okay, so here's what I need to do. See here it says on click equals left button click. So you got to find this, and then it says, hey, Lightbulb says, hey, I think you have a problem here. I think you haven't written a method called left button click. Please, Lightbulb, help me. You click on him and you say, wait, you click on this, and the light bulb appears, and you say, please create that method in my main activity. So I click it, and then this is the Java code for the app. It makes me a little method for this that I can write. So basically any code in here runs when the left button gets clicked. So this will be the Java part. We're finally going to get to the Java part in a second. So I can go back here to this other one for the right button. I can look for the light bulb, and I can say, hey, create this method for me. Now, just to be clear, that light bulb stuff is not special. If I just wanted to come in here and type this from scratch, that would also have been fine. But then you have to be really careful to type it just right with the right return type and the right parameter types. And so this is a nice way of making sure that it does it correctly without any typos in it or something. So this down here is something that runs when the right button gets clicked. Okay? So now we just want to write some code in here. Of course, the problem is we don't really know what to put in here. Like, how do I, what can I do? You know, in this environment, what can I do? Well, let me just show you first. Let's make sure this is working. So let's make it so that when you click those buttons, a little message will pop up. Okay? So let me jump to, I have a slide that I think will be useful. If you want to make a message pop up, a little pop-up message in Android is called a toast. Piece of toast. And the way you do it is you write this command, toast.makeText this, comma, and then in quotes you put the string you want to display, and then you write how long you want it to display for, which is either toast.length short or toast.length long, and then you write .show. So that line is how to just pop up a little message that appears on the bottom of the screen and then fades out after a short time. It's like println, kind of. So let's make it so that when you click the left button, it does toast.makeText this, comma, you clicked left button, comma, toast.length short .show. If you don't memorize that, you can just look it up in the slide. Over here, let's say you clicked the right button. Okay, that's it. So now I'll run the app again on the emulator. And wait for it, it's pretty exciting. I click this, it says you clicked L button, and then it fades after a second. I click this one, you clicked R button, and it fades. Okay, so we just verified that the events are happening and our code is running when we click those buttons. So that's a good step. Okay, but what I actually want is, there's a lot of stuff missing, right? I want these buttons to have different numbers on them, and I want to make it so that you have to click the right one or the wrong one and you get points or not, right? I want to wire that all up. So let's talk about some more stuff that we need in order to accomplish that. Any questions about, so far, the stuff that we built? Okay, well, so that visual editor with the design and the XML stuff, that leads to the widgets that appear on the screen in our app. If we want to talk to those widgets in the Java code, we can. And the way that you do that is that each widget has an object that it's associated with. The objects are part of an inheritance hierarchy, The superclass of all those objects is called view. So all of the different subclasses like button, text view, edit text, checkbox are all subclasses of view. They all have some common behavior from their superclass called view. Each of those objects, like every button, every text, whatever, has different methods you can call. Like you can ask it for the text, you can set the text, you can set the color. There's a bunch of different get and set kind of methods that they all have. And I want to show you how to go talk to a button in the Java code. So let me jump to the next slide real quick. So here's what you do. There is a method in your Android app called findViewById. You give it an information about what widget you want to talk to, and then it will return you the object for that widget. So what are these IDs? Well, let me jump back to the editor, the visual editor for a second. When you go back to the design view here, each of these little widgets, if you look here, it has a little name associated with it in bold on the right, top right. You see this text view 2, button, button 2. Those are the IDs of these controls. So if you want to talk to them, you can refer to them by those names in the Java code. Now, I don't like these names. They're not very descriptive. These are the default names that the editor gave us because it didn't want to force us to type in a name. If we want to give it a better name, you can do that. You scroll up and down through these properties on the right, and you pick a better name, and you type it in under ID. It says button 2. Why don't we call this one left and this one right? Or right button, and let's call this one left button. It's a little bit like variable names. We're naming these widgets, okay? Cool. So we could give better names to all of them, but I think the buttons are important. So like what if in addition to saying you click the left button, I want to change the button to have a smiley face on it as its text? Well, here's what I could do. I could come here when you click the left button, and I could say find view by ID. And what you put here, you write r.id. and then the name that you gave it in the XML place. So left button, r.id.left button. This function call returns an object representing that button. So if I want to store that, I can say button L button equals that. When it's red, it means you haven't imported this class, so you can hit Alt-Enter, or you can right-click or whatever, it'll import that class for you. You know, in Java, you have to import things to use them, import libraries. This is still upset because findViewById could return any of these different kind of widgets from the call. So you have to do one more thing where you have to do a cast into button type, because it could return a text view or a checkbox or anything, so you have to cast that. But that's the line to access that button. I see your hand, I'll call you just 1 second. Now that I have this button in my hands, I can talk to it. If I want to put a smiley face on the button, I just say lbutton dot set text to be smiley face. So now, in theory, when I rerun this, when I click the button, it'll still show the toast, but then the button will have a little smiley. You had your hand up. What were you going to ask?
I was just curious what the R object is, or if that's important.
What's R? When you write an app, all the little IDs that you put into this layout are compiled into a special class named R, with a subclass inside of it called ID, or a nested class inside of it. It's something that's wired up automatically by the build system. So I click this button, and look, there's a smiley face now on the text of the left button because I clicked on it. Yeah?
Should we make that function call anytime we want to access one of the views, or should we like store them within the class and only access them the one time?
Oh, that's a good question. Like, maybe if I know that I'm going to talk to this left button a lot, maybe I'll make a private field variable that's going to stick around for a long time. There's various reasons why I think this is better to do it locally, having to do with like more complicated stuff. Like if you exit your app and come back in a second, you can lose some of those private variables values. I don't want to go into all that yet because it's complicated, but for a lot of reasons, what we just did here is actually what I think you ought to do. Okay, so I showed you how to interact with that button a little bit, but there's a lot of stuff missing. Let's try to wire some of this together. We've got 10 minutes left, 8 minutes left. Let's see if we can get some of this dumb game to work. The whole point was I'm supposed to put 2 different numbers on the buttons, and you're supposed to pick the bigger one, right? Right now, in the app, they both say 0. So let's address the part about picking the random numbers and putting them on the buttons. Because each time you click, I want to generate 2 randomly chosen numbers and put them on those buttons, right? So let's write a method called like pick numbers. that will put the numbers on the buttons randomly. Because right now they just say 0. So how do I do that? Well, I want to grab the left button and the right button. So I'm going to do something similar to this here. So if you don't mind, I'm going to cut this and I'm going to paste this up here. I'm going to grab the left button and I'm going to grab the right button. The ID that we gave that was right button. Do you see that? So I've grabbed the objects for the 2 buttons. I need to pick 2 random numbers and put them in the buttons. Okay, well, how do you pick a random number? If you took our 106A course, there's a class called Random Generator. In real Java, there's a class called Random. Random Randy is a new random. And let's import that. If you want a random number, you can say randy dot next int. And you can pass in the max. So let's do like a max of 10 or 9 or something. So let's do like int num1 equals that. We have to pick 2 random numbers. Int num2 equals that. And let's put those numbers on the buttons. How do I put the numbers on the buttons so you can see them? I have to say set text, right? So let's do left button set text num1 and right button set text num2. Now I think that shouldn't work. I thought set text required a string. Because like if you want this int to be there, you probably have to convert it into a string. So if you want the num1 to be a string, you could say string.value of num1. And if you want, same thing for num2. You know what I mean? Like to turn the number 4 into the string 4, so you can set it as the text of the button. So now I picked random numbers. There is one thing. I don't want the 2 numbers to be equal. I want one of them to be strictly greater than the other one. So I think technically if we want this to work, maybe what I should do is I should do like int num1 equals 0, int num2 equals 0, while num1 equals num2. Do that. Re-roll if they're the same, basically. You know what I mean? So that's just a quick fix so we don't have a tie. Okay? So pick 2 numbers, put them on the buttons. Now, if I just run this now by clicking the play button, it'll start with 0 and it won't actually execute this code. So when do I want this code pick numbers to run? When do I want to do that?
After a button's been pressed.
Yeah, that's one time. Like when you pick one, I'll verify whether you were right or wrong, but then I want to roll the numbers again. And where else? When it first loads up, I want to do it once there. So this thing, I didn't talk about this. This is some code that was generated for me. This is my little class called my activity. Then this is something called onCreate. We'll talk about more next time. This is a method that's like main. It's like your app is starting up. Any code you want to run on startup, you can put there. And I'll talk a little bit about what this existing code does, just to kind of leave it. Just it generated that for me. I need that there for the app to work. Underneath that, I can say pick numbers. So when the app's loading up, pick the random numbers and put them on the buttons right away. Okay? So now, down here, left button, when you click the button, I want to see if you're right or wrong. I want to see if you're right or wrong. And then at the end of that, I'm going to probably say pick numbers again. Let's write the code to see if you're right or wrong. So how do I see if you're right or wrong? Well, I need to go figure out what the numbers are. Now, you were asking about should I make like a private variable. So I could do that. Up here, I could say like private int num1, private int num2. And then here I could like 0 them out and I could, So now I guess the point is if I pick the numbers, then later down here, I'll still have those. So I could do something like, if you click the left button, you're telling me that you think num1 is greater than num2. That's basically what you're saying, right? So if it is, I could say like, correct, you did it. And else, if it isn't, then you got it wrong. So like, I could say like, you are stupid. Whatever, I don't know, something. I could insult the user. Some kind of message like that, right? And then afterward, I need to pick the numbers again, pick new numbers. And I could have pretty similar code. This is a little bit redundant. You could imagine a helper function for this, but it's pretty similar code when you click the right button, except in the right case, you're saying that you think num2 is greater than num1, right? What else do we need to do? There's something else missing, right? The points, you're supposed to score points when you play, right? So maybe what I'll do is I'll say private int points. And when you initialize the app, points are 0, right? Now down here, if you get one correct, you get a point plus plus, points plus plus. And if you get one wrong, you get a points minus minus. Same thing here. If you get it right, you get a points plus plus. If you get it wrong, you get a points minus minus. I have to show them the number of points on the screen because it's just this int. They can't see this little private int. I have to display it to them somewhere. We've got a label that displays it. Down at the bottom, it says points 0. See this? This little thing. Now, it's called text view 3. Maybe I'll give this a better label. I'll call it like points view. I don't know. That's fine. Points view. So now down here, maybe what I'll do is I'll say, well, you need to update the points view. So I'll say find view by ID, r.id.points view. That's going to be my way of talking to that text component. And that component is a text view. And I'll call it points view equals text view to cast, right? Just like with the button, I have to tell it what comes out. And now once I have that, what do I do to it? I have to set its text, dot set text to be points colon plus points, right? I updated the points, so update the text, and then pick new numbers, ready to go. So let's try it. Oops, I didn't do it up there, did I? Uh-oh, no. That's the worst when you forget, and now it's doing all the work to rebuild the app and rerun the app. Okay, I have to do it on both sides. So that's another argument for why I probably want a helping method here. Maybe I'll do that in a second. I think I missed out, so I have to run it again. Let's try again. So you can see it's a little sluggish, like you hit run. That's why you want to think for a second before you hit go. It's a little slower than like Eclipse or Qt Creator or whatever. Okay, so let's try it. I've got 8 and 5. It loads up with some actual numbers now. So let's simulate being a Berkeley student. That one? Hey, we were correct. Thank you. Hold your applause. Which one is bigger, 0 or 9? 9? Ooh, okay. Okay, wait, how about 4 and 6? I think it's 4. Oh, no, I'm stupid. Oh, no, I'm really stupid. So this is kind of the basic skeleton here. Yes, question?
With something when you click the correct number, there's something behind. Yeah, there's something you are correct with it.
There's something else?
Behind the toast.
Behind here?
Oh, it's gone.
Oh, it's gone now.
So I think sometimes the emulator has graphical artifacts and fuzz that don't actually reflect anything real. So I think it's okay. I think it's okay. So, okay, there's a little more to it than this. I talked about how sometimes it's bad to use these private variables. I'm going to talk more about that in the future. If I said that we weren't allowed to use these private variables, what would that mean? Like, could we still solve the problem? Like, what kind of changes would we have to make to the code in order for it to work? Yeah.
You'd have to get the text from the buttons and then convert it to an integer to then compare.
Right, like here in these methods, I'm looking at num1 and num2 int variables. Those are my private fields that you can see throughout the whole file. If I didn't have those private fields, the numbers, the two numbers, num1 and num2, they're still there. They're there as the text of those two buttons. So what I would have to do is I would have to find the button by ID, and I'd have to get the text as a string. I'd have to convert it into an int. So I could get num1 and I could get num2 by asking those buttons and converting accordingly. So it would be possible to write this without the private variables. I did it this way to kind of speed it up a little bit. Now you might say, well, why not do this? Well, I'm going to come back to it, but basically there are cases where this will get you in trouble if you have too many of these private variables. That's something we'll do next time. So I'm out of time. It's time to go. Thanks for being here, and have a great day, and I'll see you again on Thursday. I'll post this code on the web. Go set up Android Studio on your computer if you can between now and Thursday. Thanks. See you next time.